solve a problem. In your own words, this is how you describe an algorithm. Are you all right? So we are talking more about it here on this page. I just want to touch more on the algorithm. So an algorithm, we should apply an algorithm to data, and the data should be identified by name. Is that okay? Okay, so the example of that is, hold on a second, whilst I get this one. Example is if I store data T1 equal to 20, no, let's pick a constant value, 22.7, okay, or say 3.142. So here I've stored data in a variable. Are you okay? So, but the name of the variable is T1. So the name that we are talking about, identifying data by name, will bring us to the topic of variable. So we talk about it very soon, talk about what the variable is. We should be able to denote the order of operations. Okay, so we should be able to denote the order of operations. What does that mean? It means we need to be able to say that, okay, this happens before that. That happens. Okay, this instruction should be executed before that instruction. So, we were actually writing the step 1 in our first algorithm that we wrote, step 2, and I will say go to step 3 and things like that. Okay, go to step 7. So we are actually denoting the order of operations. Something should be done, but when should it be done? So the order of operations. Obviously, this also points to mathematical operations. Are you okay? We can talk about BODMAS. I hope you remember BODMAS. 2 times 4 minus 8. Okay, so operations could also, relate to that. And in algorithms, very likely, I think we shouldn't forget that this could be arithmetic operation, logical operation, or comparison operation. Is that okay? Later we'll talk about those ones as well. So the order of operations, we should be able to denote the order of operations. Express choice based on data. In other words, we can say if time is 6 o'clock hours, then do one thing. Are you okay? Maybe go to step 10. Right, so we should be able to denote the order of express a choice based on the data. Okay, choice based on data. So now it means that time, we can even say start time. Okay, so we can just say start time. If start time equal to 6 o'clock hours, then go to step 10. Okay, so if someone started at 7 o'clock, then we are not going to step 10, that kind of thing. So algorithms are, the principles of expressing algorithms, all these are part of this. So I'm actually under 6A, I'm also saying that if this, then do that, otherwise do something else. As we are saying over here, you start time in 6 hours, do one thing, go to this step. Otherwise, we can also look at going to another step altogether. Okay. Yes, so we should be able to express repetition. So repetition means that you go to a certain step, come back, go back again to that step, go back to the step. We do the same thing over, like, let's look at something like a dishwasher. Okay, a dishwasher, or maybe what do we use for washing clothes, right? For instance, what do you call that machine? Washing machine. It tells you I don't have a washing machine. Is that okay? I can't remember the name. So washing machine, there's repetition in there. Are you okay? So it turns round. That's repetition. So keep going, keep going, keep going until you do a certain number of what runs. Are you with me? And then so that's repetition. It just goes round and round. Water is in it, and then soap is in there. So we should be able to express repetition in our algorithm. Is okay. So repeat this task 1 million times. So that is the interesting thing about computers. You can ask a computer to do something like 1,000,000 times, it will do it. But a human being will find it difficult to do that, something even little. Are you okay? Just go and pick this thing for me to become a whole politics. Are you okay? And then let's vote first before I go and all these things. Are you okay? Who was here before who and all that, but the machine can be told to do the same thing, the same task and activity, again and again and again and again. Are you okay? So that is it for you. Now, in our bit to write flow charts, one of the tools that help us is what we call the flow. In our bit to write algorithms, one of the tools that help us in writing a computer program is not only the algorithm, but the flow chart as well. Are you okay? So the flow chart, the algorithm, they cannot help you to write it because at the end of the day, we have to write code. What we need to write is code. It's not the algorithm. The algorithm is only helping us to think, helping us to plan the logic. Are you okay? So we are writing something to tell, okay, this is how we want it to do. Now let's write it in a language that the computer can understand. Then you start coding it. Are you okay? Yeah. All right, so a flowchart is a diagram of the sequence of operations in a computer program. So it's a diagram. The focus is a diagram. Think about a diagram. So the steps the algorithm must take are shown as boxes. Are you okay? So we're gonna use boxes, okay, to represent the steps. The boxes are connected by arrows, okay, to show the order in which the steps should flow. In other words, flowcharts really exist even in mechanical engineering. It exists in electrical engineering. It exists in a lot of places. In fact, even in cartography, when we start looking at map production, there are, flowcharts are there. Are you okay? Just that they are called a different name, but they are basically flowcharts. All right. So we use boxes. Okay, boxes, we draw boxes and then write the instructions in there. So flowcharts are used in designing, analyzing in other fields. I think I've just talked about this. All right. So there you go. In the flowchart, we make use of these shapes. We make use of the rhombus, okay, for data input and output. Then we make use of the diamond shape to represent the decision points within the program. In other words, if we need to decide what to do, we use this symbol. Then we use an oval shape to represent the start or end of the program. Then this is the arrow. The arrow is used to represent the program flow. So where are we going from here? So if I'm able to draw an arrow right now, okay, so that I point it here, that means that the program is flowing in that direction. If I point up here, it means that the decision is actually in that direction. So we will actually look at it, how this is done. Okay. So we also have the rectangle. The rectangle is used to represent computations. In other words, if you want to carry out some kind of process that, okay, do something, okay, if you want something to be done. Of course, the oval shape is used to represent the start and end of the program. So we start the program with the oval shape. We make inputs by using the rhombus shape, okay, or outputs. The decisions are made by using the diamond shape, etc. And then we are good to go. Okay. All right, so start and end symbols, circles, ovals, rounded rectangles. So start and with we write a start and end words inside the oval shape. Okay. And we talked about the flow. I think these are all repetition. Are you okay? processing, rectangles are used. Are you okay? Okay, a condition or decision are represented by a diamond. Call it a rhombus if you like. These typically contain yes or no questions. Okay, so I'll just show you an example of how the decision is made. Okay, so if I equal to 10, then you decide which direction to go. Yes, you go to the right. No, you go down. Okay, so this is the diamond shape. Okay, this is diamond shape, and it's used for decision making. All right, so there's a condition. Is all right. So the condition is that if I equal to 10, so we could really make it a T and say that if T equal to 10, so T could be temperature, for example. So if the temperature is 10 degrees Celsius, then switch on or switch off. You know, this is how the diamond shape is used. And the inputs, let me try and do one for an input for you. Okay, so on top of the decision, let me actually clean this one. Clean the board. Okay. So what we can do is that before we got a T, so the input T equal to 10 could have been taken up here. As you say, it gets T, okay, maybe an integer. T is an integer. So here we are using a rhombus. Okay. This is a rhombus. And it's for inputs. Okay, we are making an input. All right. All right, and then we are saying T is not 10. Is that okay? So T is not 10. Then do one thing. Okay.
Okay.
Let's go back. In fact, so what it means is that we are not going to do anything. If T is not 10, we are just going to go back up there and check the value of T. So we're just going to draw this line here. Just going to extend it up. Okay. Probably we keep on checking the value of T. So here we have some kind of repetition happening. But if the value is 10, then we can decide that, okay, let's end it. Okay, so this now becomes an output. This box this rhombus I just will becomes an output. Just say end. Oh, you don't end shouldn't be an output. It's not a good one. Let's say high. We can report that the value is high, something like that. Okay, so T could be maybe blood pressure or something like that, or temp. Like I said, if the person maybe the person has a high fever. Are you with me? So this is a program. This simple thing we're doing is, becoming something like a program. Are you okay? Right. So there you go. You see how the boxes are being used, right? So which box haven't we used? We haven't used the stats box, so we could do, which is a circle or what? What's the other one? If it's not a circle, then it's what? This one is not a circle. What is it called? An oval shape. Are you okay? So start. Yes. And then this is the flow of the program. All right, so starts, and we can we can probably end the program maybe somewhere here. Can just do another rhombus. Which shape haven't we used so far? And I think we use the rhombus, we use the decision. Basically, this is it. Yeah. I don't see us now. So we need to have arrows showing the program flow. Okay, we need to actually here we can't have an arrow here. There should be just a line. So this arrow goes all the way up. Okay. Please, if you don't understand it, tell me, because you'll be doing this yourself. You're doing this yourself. If I ask you to do it, if I will be asking you to do it. So if you have it, if you don't get what I'm doing on the board, just ask me. I know sometimes you go quiet on me, but it's okay. All right, so that's what we are talking about on this page. Everything you are seeing here, this is what I want. That's what I've shown you on the whiteboard. Okay. The use of the oval shape or circle, the rhombus, and then the diamond shape for decision making. All right. So this is how it works. We can apply it. We can actually do an example of an algorithm or maybe a flowchart. Okay, so let's try to understand some of these basic things. Then we do another example. Excuse me. Okay, so an algorithm example, an arithmetic sum of two numbers, current deposit and an account balance to obtain the current balance. Okay, that's, I can't really see, this one is covered up, but obviously it's a very simple one. Okay, an arithmetic sum of two numbers, current deposits, okay, and an account balance. So if you make a deposit in your account balance plus the amount that you deposited should give you what your current balance is. That not the case? So that's like easy peasy, very you start, you simply add, no decision will be made. Are you okay? So you can see that this one is not even, I don't know if it's even worth looking at. You just put a start here. All right, these two are the same. What we have on the left and what we have on the right are the same, just that they've been written. One is wordy than the other. Are you okay? So here there's a lot of words being put in the box. Are you okay? Whereas on the right hand side, we have few words. We are using symbolizations, representations of the same thing. Add an account balance and current deposit to obtain the current balance. You can just write CURL bar equal to ACC bar. So these become the so-called variable names. Are you okay? Later we will get to know that programming will point you to algebra. Are you okay? So in algebra, remember we have variables. So please get used to it. We are going to be talking about, variables very soon. It's coming to you in the cinema near you. Is that okay? All right, so basically start, then end. Okay, this is the simplest algorithm you can ever come across. All right, so you done. I just want you to do one thing. Just tell me what my current balance is when I make a deposit. That's the job you're supposed to do, or that's the problem I have. I don't have any other problem. I just want you to just add it, update my bank balance. You see, what really hurts is when you actually put money in your account and it doesn't reflect. It's really hurts. So this one is worth selling. Are you okay? So anybody who is interested, see me. So we go and sell it. Is that okay? Okay, that's a big joke right there. But I hope you are following it. It's very important. Okay. Yes, so here we are introducing a decision point. Previously, what I showed you didn't have any decision. Okay, no decision will be made. But now we are saying that let's introduce a decision. Is your current balance greater than $100? If it's not, do one thing for us. Is that okay? Like the Indians say, do one thing, yeah. So anything the Indians say, they'll say do one thing. So no, if yes, if your current balance is greater than $100, then calculate an interest on the current balance. What it means is that there's a certain amount of money that people put in their account that does not attract any interest. It's possible to have that kind of thing happening. Is that okay? So in that case, here we are attract, but I think most accounts, whatever you have in there, they work out an interest based on whatever you have. But let's assume that your account attracted different interest based on how much you have. Then in that case, this program will do a wonderful job. Are you okay? And then again, what is missing in this program is a start. Are you okay? Start and the end is missing. It's all right. So we need to start it, end it nicely, but this is just so easy. This is no, algorithm to write. At the end of this, in fact, by the end of this program, you all write a program for me. So please start asking yourself, am I ready to write a program? Is all right? Okay, let's move on and see if there's something more we need to know. So flowcharts, okay. Well, which one is this one? Maybe I may not be even interested in it. Okay, diagram A and B. Let me see if I have a diagram. Okay, all right. Hey, how do we come back to this? I think we are missing something here. Okay, great. Let's see if there's something interesting here we can actually do. Computation of sum of two numbers carrying the proceed. Okay. I think let's keep all this. It's all right. It's a repetition of what I've already talked about. So let's go back and look at an algorithm to compute, to find out if a number is odd or even. So at the beginning of every program, if you want to write a program, you need to first understand the problem. Is that okay? So how do we know if a number is odd or even? So we want to write a program to find out if a number is odd or even. Okay, so can I hear it from you, class? How do we get to know if a number is odd or even? So let's discuss it. If I have a number like, we have 10 minutes. After the 10 minutes, please, let's rejoin and then we end the class. Is that okay?
Okay.
If I have a number like 9, okay, 2 and then 1. Let's even add 4 to it. How do we know that 1 is odd, 2 is even? We are going to write a program. Any number we put into the program, it will tell us whether it is odd or even. How do we know that 9 is odd and then 4 is even? Okay, so let's have a little discussion. Yes, Juliet, there are only 3 of us in the class. Is that Anna? Maybe they are not. There are
No,
more.
there's more. They are
1,
all
2,
here.
3. Okay, there are 5 of us. Okay, including me, we have 6. All right. So then I should be asking you. Is that what you are saying? I should be asking
Say,
you.
ask them. Ask them. I've answered.
You've
Yes,
answered a
they've
lot.
answered to me. Ask them.
Yeah, it's true.
Yes.
Yes, you've contributed
Ask
a
the
lot.
rest.
Okay, so this Christmas I'll be giving them turkey. I won't give you some. Okay. Okay, Ben. Ben, are you there? Let me hear from you, Ben. Okay, Nancy. Timo. Timo.
Hello, sir.
How do we know that 1 is odd, 2 is even, 9 is odd, and then 4 is even? How are we able to tell
Cause,
that?
cause one cannot be divided by two.
Okay, 1 cannot be divided by 2. That's why it's odd. Okay,
Yes.
let's try. Why is 2 even?
And cause it can be divided by two.
divided by 2. What do you mean by can be divided by 2? That's not good enough. We can divide 2 by 2 and then not have any remainder, isn't it? All right, so that's good. So 9, if you divide 9 by 2, we will have a remainder, isn't it? Right. So that is how you write an algorithm. You try to understand the problem, then you try to actually come up with a way to solve the steps to solve it. Is that okay? So if I take a number, any number at all, okay, then 2 times a certain number I plus the remainder, are you okay? Is what really kind of gives me an idea whether the number is odd or even. I don't know if you are following what I'm saying. Is okay. So if you have a number like 4, then 4 is actually, we're able to tell that 4 is even by just doing 2 times 2 plus 0, isn't it? All right. So the programmer needs to understand this very well because he wants to write a program, and the program should detect if the number that is being supplied is even or odd. Are you okay? So how do we know that 3? So immediately we get R to be 0, the remainder to be 0. This is what children are learning in primary school. So I think this is not difficult. Are you with me? All right. So let's follow it. How do we know that 3 is odd? 2 times 1 plus 1. Are you okay? All right.
Yes.
So you realize that this value here, are you okay? The values here are actually changing, and then we are having a remainder of 0 or 1. So if we want to actually determine if a number is odd or even, then we should simply run through, repeatedly change. We need to change the values around here. Okay, and as we change them, then we look out for whether R has become what? 0 or 1. Are you okay?
1.
So if R becomes 1, it means the number is what? Odd. If R becomes 0, then the number is what? Even. Please, are we on the same page on this?
Yes, sir.
Yes, sir.
I think it's basic. It's basic.
Yes, yes. This
All
one
right.
is.
Okay, great. So now, what's the first step? So step 1, we need to get a number, isn't it? We need to get a number, and we don't know what number it is. Are you okay? So the number can be 137, and then we want the program to determine whether it is odd or even. What will be the step 2? Step 2, we take the number n, or we take the number 2, and then we multiply it by I. Are you okay? So we are going to do this repeatedly. We don't know, we start with 1. Are you okay? So we check if I times this number, all right, then we subtract this from the value n. Is that okay? So let me actually, so n minus 2 times I. N minus 2. So in programming, multiplication in programming, we use the asterisk. Are you okay? So that is times. All right. Okay, so now we want to find out what is this value. Okay. Let me clean this side of the board. I hope my thing is not going to mess up. Let me get it. Okay, maybe this is from a different layer. Okay. So what is this value here? Oh, okay, great. So we want to now find out what the value of this is. Then if this value is less than, so let's call this R, isn't it? Okay. Now in programming, the left hand side of the equation is given to the right hand side of the equation. So instead of us writing this, okay, we are supposed to be writing R equal to
R
N
equals
minus
to N minus
2
2
star I.
times.
Okay. So in programming, we don't write.
Sorry.
Okay, that's fine. So we don't write the top one. Okay. We write this one. So step 2, we find this value. Step 3, let's check what that value is. R. Are you okay?
Okay.
So is R equal to, no, another thing we need to do is R equal to 0, right? If R equal to 0, then what do we do? It means
It's an even number.
it's an
Even.
odd number, even number. And then
Even number.
exactly, and if it is 1, then it's
Odd number.
odd number. But what is the problem here? The problem is that we need to set I to be, we need to initialize I. Are you okay? We need to initialize I. So we need to set I. So in a step 1A up here, then set I equal to, so we can actually do I equal to 1. Are you okay? To initialize it. Okay, and then we can now start increasing the value of I. Are you with me? All right. Okay. Why are we doing that? Why do you think we are doing that?